Let's explore the mean value theorem using a specific example. The question asks us to prove the mean value theorem for the function f of x equals 3 plus 2x minus x squared on the interval from 0 to 1. Let's first recall what the mean value theorem states. For a function that is continuous on a closed interval a, b, and differentiable on the open interval, there exists at least one point c between a and b where the instantaneous rate of change equals the average rate of change. Let's visualize our function. Here's the graph of f of x equals 3 plus 2x minus x squared. We're interested in the interval from 0 to 1, where f of 0 equals 3 and f of 1 equals 4. The derivative of our function is f prime of x equals 2 minus 2x. The secant line between these points represents the average rate of change. Let's solve for the point c. Using the mean value theorem equation, we have b minus a times f prime of c equals f of b minus f of a. Plugging in our values, 1 minus 0 times f prime of c equals 4 minus 3. This simplifies to f prime of c equals 1. Since f prime of c equals 2 minus 2c, we can write 2 minus 2c equals 1. Solving for c, 2c equals 1, therefore c equals 1/2. At x equals 1/2, the tangent line to the curve has the same slope as the secant line. We can verify that 1/2 is indeed between 0 and 1, satisfying the mean value theorem. Therefore, we have proven that the mean value theorem holds for this function on the interval from 0 to 1, with c equals 1/2 being the point where the instantaneous rate of change equals the average rate of change.